All right, let me work in some problems here from Math 1325. Working on the first derivative. Uh-oh, what is that? Sorry, I'll get going here. All right, we are on page 644. I am looking at number 37. Okay, so number 37, and that is f of x is x cubed plus 4x minus 5. And we're asked to find where the function is increasing, where it's decreasing, and any local extreme values. So I want to know where f is going up, I want to know where f is going down, and I want to find any local extrema. That means any local maximums or any local minimums. All right, so what we'll do is we'll start off by first taking the derivative, and that's going to be 3x squared plus 4. And now we will figure out where the derivative is 0. So we take the derivative, set it equal to 0, which means we take 3x squared plus 4, set it to 0, and we are going to run into a problem right away here. 3x squared equals negative 4. Subtracting 4 on both sides, and then dividing both sides by 3, we get negative 4/3. And I know I have a problem right now because there's no way I can square a number and get a negative number unless I use imaginary numbers, which we're not doing. So there's no solution here. And because there's no solution, that means that this derivative of this function is either always positive or always negative because it's never 0. So the way we can figure out whether or not it's positive or negative is just picking any point at random and plugging it into the derivative. So let's plug 0. Let's just take 0. Let's plug it into the derivative. We plug 0 in here, we're going to get 4, which means that we get a positive answer. So if we plug in 0 into the derivative, we get 4. That's greater than 0. That means my original function is going up here. So my original function here, f, is going up. And there's no other places that it would be ever going down, because the fact that the derivative is never 0 means that this thing never goes up and flattens out to come back down. So the function is always going up. So I'm ready to answer the question. The function is going up all the time. It's never going down, empty set. And that means I do not have any local maximums, and I don't have any local minimums, none. Right? None. No local max, no local min, because in order to have a local max, we have to go up then down. In order to have a local minimum, we have to go down then up. So we don't have that happening. So no local extrema, never goes down, goes up all the time. All right, that's our first question. Let's take a look at the second one. And I believe the second one, 39, I did in class. Yes, I did. Oh, wait, but the video didn't come out. That's right. So I'm going to have to do number 39. I'm going to need all that again, but it's all right. So for 39, new function. The function is f of x is 2x cubed minus 3x squared minus 36x. And we are asked to do the same thing. Where is it going up? Where is it going down? Any local extrema. So I take my derivative. When I do that, I get 6x squared minus 6x minus 36. That's just using my power rule up there. And now I'm going to set this equal to 0. And when I do that, I set 6x squared minus 6x minus 36 equal to 0. And the way that I would do this is I would factor a 6 out. And then I would divide both sides by 6. And that would kill that off, and this side would still be 0. So what you get is x squared minus x minus 6 equals 0. And that leads you to factor. Okay, we can factor that quadratic, x minus 3 times x plus 2 equals 0. And that leads us to two solutions, 3 and negative 2. Now what I do is I draw a number line. I plot these points. I make sure I get them in the correct order. That splits up my number line into three sections, 3 regions. And now I'm going to pick 3 test points, 1 in each region. I get to pick whatever I want. So how about negative 3, zeros between negative 2 and 3, and then 4. And then I will take these 3 values and plug them into the derivative to see whether or not I get positive or negative numbers. So let's take negative 3 and let's plug it into here. So if I plug negative 3 in there, I get 6 times negative 3 squared minus 6 times negative 3 minus 36. All right, negative 3 squared is 9. 9 times 6 is 54. Minus, now this can actually become a plus because it's negative times negative, so plus 18, and then minus 36. And I don't even really care what that number is, I just know that it's positive, right? Because if I do 54 plus 18, take away 36, that'll be a positive number. That means over here at negative 3, since that was positive, my original function's going up here. Then I plug 0 into the derivative. So when I plug 0 in here, it's pretty easy to see that's going to go to 0, that's going to go to 0. Just be left with negative 36. So negative 36 is what I get. That's less than 0. So these are separate problems here. So I get a negative number for the derivative when I plug 0 in. That means the original function goes down here. And then if I plug 4 in, I'm not going to do the work, but if you plug 4 into this, you will get a positive number, which means that my function will go up over here. So that's it. From that picture right there, we should be able to answer everything we need to for this question. First of all, where is the function going up? Well, it goes up to the left of negative 2, which is negative infinity to negative 2. It also goes up after 3, so union from 3 to infinity. Now, where's the function going down? Well, that's going to happen between negative 2 and 3. All right, now let's talk about any local maxes. Local max, do I have any? Let's see, where do I have a local max? Anywhere I go up, then down, and that happens right here, negative 2. We go up, then we come down. So I'm going to have a local max at x equals negative 2. And let's go ahead and just figure out what the value is there. The original function's value at negative 2. Let's just figure it out. So if we plug negative 2 in here, to the original function, we get 2 times negative 2 cubed minus 3 times negative 2 squared minus 36 times negative 2. So I don't think the book asks you for this part, but I'm going to ask you for this on the test. I want to know what the actual maximum value is, what that local maximum is. So how high is your function here? The only way to figure that out is to take negative 2 and plug it into the original function. So negative 2 cubed is 8. And then times 2, you get negative 16. Negative 2 squared is 4 times negative 3, it's negative 12. And then we're going to have a negative times a negative here, which is going to be positive 72. So what do we get there? It's negative 28. So 72 minus 28. I'm just doing this arithmetic, making sure I get it right here, for 44. So 44 should be how high that function is. That is locally the highest point, so it's the top of the hill. So if we went to negative 2, went up 44, put a dot, our graph would go like that. Okay, now to find the minimum, if we have a minimum, local minimum, we're going to be looking for anywhere where the function goes down then up, and that happens here at 3. We go down then up. So local minimum at x equals 3. And so now what I'll do is I will plug 3 into the function to see what that value is. F of 3, so we plug 3 in there. 2 times 3 cubed minus 3 times 3 squared minus 36 times 3. I'm just going to use my calculator for this. I don't feel like doing that. Oh, I messed up. 2 times 3 cubed minus 3 times 3 squared. Get negative 81. Negative 81. So the minimum happens at x equals 3. The actual minimum value is negative 81. So that means, again, if I went and I tried to graph that original function, if I went out to 3, I would have to go down 81, put a dot, and my graph will go down and then back up there. All right, that's 39. Let's look at 41. All right, geez. For 41, f of x equals 3x to the 4th minus 4x to the 3rd plus 5. Okay, let's take our derivative. 12x cubed minus 12x squared, and that's it. That's the derivative. There's no more work to do there. Then I set this derivative equal to 0. So I take 12x to the 3rd minus 12x squared, set it to 0. To do this one, I'm going to factor out a greatest common factor first of 12x squared. That'll leave me with x minus 1. And then I set each of these factors to 0. So I set 12x squared to 0. I set x minus 1 to 0. The only way I can square something and then multiply by 12 and get 0 is if x was 0. And here, if I move the 1 to the other side, I get x is 1. So I have two answers, 0 and 1. And then I'm going to pick test points here at negative 1, 1/2, and 1, not 1, 2. And then I'm going to plug those into my derivative. Unfortunately, we have to plug in a fraction, but that's okay. Give me just a second because someone's knocking on the door. Yep. Have a good weekend. Okay, sorry about that. All right, so I'm plugging -1 into the derivative. Here's my derivative. And when you plug -1 in there, 12 times -1 cubed minus 12 times -1 squared, you're going to wind up getting, see, -1 cubed is -1, then times 12, so -12. -1 squared is +1, so minus just 12. That's going to be -24. That's a negative number. That means my original function is going down here. Now let's plug in 1/2. 1/2 is going to be a little harder. 12 plugging into the derivative. 1/2 cubed minus 12 times 1/2 squared. So when I cube 1/2, that's 1/2 times 1/2 times 1/2. That's 1/8. And then minus 1/2 squared is 1/4, so 12 times 1/4. And this right here is the same as 12 over 8. And this right here is the same as 12 over 4. And, well, depending on how you want to do this, I'm going to reduce the fractions. Let's just make this 6 over 4. And the other one, let's leave it as 12 over 4. I know that you could, that's just a 3, but let's just do this. Same denominator, 6 minus 12 is -6 over 4. This is a negative number. That's all I needed to know. Original function is going down there. And then if we plug in 2, I won't do it, we're going to get a positive number, so it'll go up. All right, so where is my original function increasing? Well, from 1 to the right, so from 1 to infinity. And it's decreasing to the left of 1. All of this stuff, it's always going down. So I'm going to say -infinity to 1. As far as a max is concerned, do I ever go up and then down? Well, no, I'm down, down, then up. So I never go up, then down. So there's no max, local max. As far as a minimum, do I ever go down, then up? And yes, that happens here at 1. I go down, then up. So this happens at x equals 1. So I'm just going to plug 1 into the original function and see what I get. So if I plug 1 in here, I get 3 minus 4 plus 5. So that gives me 4. So I have a minimum value of 4, a local minimum value of 4, and it happens at x equals 1. Okay, let's move on. Number 55. So what we want to do here is find where it's increasing and decreasing and sketch the graph. So this is going to be a little more involved for number 55. Wants us to sketch the graph and add any horizontal tangent lines. Number 55. F of x is x cubed minus 3x plus 1. So let's go ahead and take our derivative, because that's what we're going to need to work with. 3x squared minus 3 is our derivative. We're going to set that derivative equal to 0. That's an x equals 0, which means set 3x squared minus 3 equal to 0. Let's move 3 over. Let's divide by 3. Now let's take the square root on both sides. And when you take the square root on both sides, you have to do plus or minus. So you do square root here, plus or minus. You get x is equal to plus or minus 1. So there are two answers there, two numbers that are important to us. -1 and +1. So now I pick some test points. So I have a test point here, how about -2? Nice test point here is 0. Nice test point here is 2. All these numbers get plugged into the derivative. So there's my derivative. When I plug -2 in there, -2 squared is 4. 4 times 3 is 12. 12 take away 3 is 9. This is going to be a positive number. That means my original function is going up here. When I plug in 0 into this, I get negative 3, negative number, so I'm going down. And when I plug in 2 into here, I get the same thing I did when I plugged in negative 2. I get a positive number. So f goes up here. All right, so let's try and figure out where is this function going up? Well, from negative infinity all the way up to negative 1, and then also from 1 on to infinity. So to the left of negative 1 it's going up, to the right of 1 it's going up. That's what that says. My function is going down between negative 1 and 1. And now what I'm going to do is I'm going to try and draw a graph. All right? So here's what I'm going to do. Here's my x and y axes. I'm going to take these two nice critical numbers I had, 1 and negative 1, and I'm going to plug these numbers into my function. So if I plug in, let's plug in, so I'm actually finding, just so you know, I'm finding f of negative 1 and f of 1, both of those values. So not into the derivative, but into the original function. So if I plug in negative 1 here, I get negative 1. Negative 1 right there with the negative 3 is going to become plus 3, and then plus 1, which gives me 3. So that means at negative 1, I'm up here at 1, 2, 3. That's a point on my graph. And then if I plug in 1 into the function, see what I get. I plug in 1 here, I get 1 minus 3 plus 1. 1 minus 3 plus 1, which is going to give me negative 1. So at 1, I'm at negative 1 like this. And now what we're going to do is use the fact that to the left of negative 1, I've got to be increasing. So my graph has to be coming up like this. Between negative 1 and 1, so between these two, my graph has to decrease. And then past 1, it's got to go up. So I think this would be a good graph. I go up, now I start coming down, and then I have to go back up again. So that's what my graph basically looks like. And I have horizontal tangent lines here and here. And that corresponds to when we set my derivative equal to 0. 0 means 0 slope. So slope is 0, slope is 0. It happens at 1 and negative 1. There you go. That's what we're looking for. Okay, number 57. Can't believe it's already 1 o'clock. All right, so number 57. We have f of x is 10 minus 12x plus 6x squared minus x cubed. Let's take our derivative. Derivative of 10 is 0. Derivative of this is negative 12. Derivative of this is plus 12x. Derivative of this is negative 3x squared. So there's my derivative. And now what I'd like to do is set that thing equal to 0. Right, so I'm going to take this derivative equal to 0. So I'm going to take negative 12 plus 12x minus 3x squared, set it to 0. Now, this is a quadratic, so we could solve this many different ways. What I'm going to do, because there's a negative in front here, is I'm going to notice I can pull out a common factor. I'm going to pull out a negative 3, and that's going to leave me with 4 minus 4x plus x squared equals 0. So let's just double check that. If I multiply here to here, I get negative 12. Here to here, negative and negative is positive, and then here to here, I get a negative 3x squared, so that works. Then I divide both sides by negative 3, which leaves me with this quadratic Okay, so I got rid of the negative 3, divided both sides by negative 3, and then I just rewrote this in a different order. It's the same expression, just rewritten. And I look at that and I realize, you know what? Does that factor? Let's see, x minus 2 should work. So if you FOIL this back out, you'll get this. So I'm trusting you can factor that. These are the same factors, so you only have one solution, and that's 2. And that's good because when I go to my number line, it means I only have one point here. So I can test two numbers here. How about 0? Let's go with 3. And those get plugged into my derivative. So if I plug in 0 into the derivative, right here, I plug in 0 into this, kills that, I just get negative 12. So I'm going to have a negative number here. It means my original function goes down. And if I plug 3 in here, you can check it for yourself, but if you plug in 3, you should get a positive number. And so that means my original function goes up. Now I'm going to try and graph this. Oh, I didn't state where it's going up now. The original function goes up from 2 to infinity, and the original function goes down from negative infinity to 2. So that's from this right here. Now my graph. I'm going to go out to 2. 2 is the only point that I really had information on. I'm going to take this 2, I'm going to plug it into the original function. So I want to know real quick, what is f of 2? So plug 2 into this. 10 minus, let's see, 2 times 12, so that's 24, plus 2 here, 2 squared is 4, times 6 is 24, and then minus 2 cubed is 8. And these 24s cancel, and you just get 10 minus 8, which is 2. So at 2, when you plug 2 in, it spits out 2. And I know that my function goes down and then back up. You see here. Yeah, hold on a second. Something seems to be, no, oh, you know what? Hold on, I jumped the gun. I jumped the gun, my mistake. When you plug in 3, when you plug 3 into the derivative, let's double check that. Plug 3 in here. I said it was positive. I screwed that up. Plug 3 in here. I'm going to do it right here. Negative 12. Then you plug in 3, you get plus 36. Then minus 3 squared is 4. 3 squared is 9. 9 times 3 is 27. And if you put these together, you're going to still be a negative number. I got ahead of myself. I apologize. So it's negative, negative. That means it's still going down here. It's still going down. And that means it's going up never. And it's going down always. So when I go to try and draw this, it goes down and down. It goes like this, and then it keeps going down. So it goes down and then keeps going down. So something like that is what it looks like. All right, I'm sorry. I should have actually taken the time to plug that 3 in. All right, let's look at number 59. Oh, I don't have any horizontal tangent lines, by the way, that I can see. It appears, though, hold on, it appears here that we should have one at 2 because of my slope is 0. So when I come back to this picture, I need to kind of tweak this a little bit. Let me do it like this. There we go. So you can see here the slope of the tangent line. We have a negative slope, and then it kind of, just for a second, just for an instant, right there, it flattens out, but then it goes back to being negative. So there's my horizontal tangent line. All right. This board is hard to erase. All right, 59, x to the 4th minus 18x squared. take my derivative, 4x cubed minus 36x. Set that equal to 0. So when I set that equal to 0, I notice I can pull out a 4x. And when I do that, I'm going to be left with an x squared here minus 9. And I need to recognize that x squared minus 9 is a difference of squares. So that's something I need to recognize from a previous college algebra class. And now I have three things, 1, 2, 3, and I set each of them equal to 0. Set that to 0, that to 0, that to 0. You're going to get three answers: 0, -3, and +3. So on my number line, I'm going to have 0, 3, -3. I'm going to have to test 1, 2, 3, 4 points. -4, -1, 1, and 4. Those get plugged into my derivative. F prime of -4, F prime of -1, F prime of 1, F prime of 4. Okay, so I think I'm still gonna be lazy here, all right? And I'm going to not plug these in. I'm gonna let you do that, but I'll be more careful with my calculation in my head here. So when I plug in -4 here, I should get a negative number, which means it's going down. Then when I plug in -1, I should get a positive number, which means it goes up. When I plug in +1, I should get a negative number, which means it's going down. And then lastly, when I plug in 4, I should get a positive number, which means it's going up. So it goes down, then up, then back down, then back up. So now I'm going to go graph this. And I have important points here at 0, at 3, and at -3. And so I'm going to figure out from the original function what's f of -3, what's f of 0, what's f of 3. All right, I think f of 0 is the easy one because you just plug 0 into the original function, you just get 0. So that point's there. And then when I plug in -3, what do I get? So I'm going to plug -3 into the original function. Get -3 to the 4th minus 18 times -3 squared. So -3 to the 4th, that's 81. I already did this one. Okay, that's 81 minus, let's see, that's 9 times 18. 18 times 9. That's 90. So I'm going to get a negative here. What am I got? So 18. -81. So this is -81. -81. So here, at this point, I go down -81. And here at 3, when we plug 3 in, you're going to get the exact same answer, -81. It's going to be like this. All right, so here are my points. Here, here, and here. And I should have horizontal tangent lines at all these points. My graph to the left of -3 needs to come down, so I need to come down into that point. And then between -3 and 0, I've got to go up. So I'm going to come back up to this point. Once I get to 0, it's going to be a local maximum. I've got to come back down. And then this is going to be a local minimum because I go down then up. So it's going to have to go like this and then back up like that. So this is the graph right here. All right, so for number 61, we're going to skip it and not do it. Let's see if that takes care of everything from this section. It does. Okay, that's it for that section.